Okay, one of the most difficult subjects in calculus is trigonometric substitution, but if you break it apart into steps, it's actually pretty manageable. So let's go over it. Okay, so I have the following example. Now, depending on the kind of square root that you have, your substitution is different. And what I also want you to understand is why we're using a certain substitution. Okay, so if you see a root that looks like this, there's just some number minus x squared. In this case, you want to have a substitution a sine theta. By the way, you can also use cosine, but usually we use sine. Okay. Then we also have the same thing, but with the plus sign. So here we are looking at a tangent theta. And finally, which is what I have, is when you start with the x squared, but then you subtract the number. And here I'm using a secant theta. Now, why is a substitution recommended for each case? Because the main idea here is to get rid of the square root. And how do you do that? Well, not by breaking it apart. So if anybody's thinking that square root of x squared minus 64 is just x minus 8, that is very, very bad. You cannot break a square root at a minus. Okay, so that's not working at all. But the idea is this: use trigonometric identities, and using appropriate identities, you can get rid of the root. So if you can't get rid of it, then that substitution is not good. Why would it work here? Okay, so let me show you. Let's start with the expression square root of x squared minus 64. Now we are substituting what? Well, our substitution is going to be 8 secant theta. So whatever number you have over here, you take the square root of it, okay? If it's 5, then it will be square root of 5. But if it's 64, then that's 8. What happens when we substitute 8 secant theta for x? So we take this guy and we plug it in for x. Now it is going to be squared. When you square 8 secant theta, you have to square each part. Don't forget that. So you're not just squaring secant, but you're also squaring 8. So this is going to become 64 secant squared theta, and then minus 64. Then you immediately see, oh, I see there is a 64 and a 64. Why don't I pull it out? And you can, so you factor it out. From the first term, you took out 64, so secant squared is left. And then minus, well, what about I took out 64, so what's left? Well, this is like times 1, so think of it as times 1. And here is the main idea. We're supposed to use trig identities. So what is the corresponding trig identity I'm talking about? Well, that would be tangent squared plus 1 equals secant squared theta. So why does it work? Oh, my squared is kind of weird. Okay. Well, it works because when I subtract 1 from both sides, I will see that tangent squared equals secant squared minus 1. And I immediately see, oh, I have it right here. That's why the substitution works. Okay, so if I tried something else, like tangent squared minus 1 is nothing. Only tangent squared plus 1 is something, but then it wouldn't work. But now it works. So here it's going to be 64, and then secant squared minus 1, that's tangent squared. So then when you take the square root, you have your 8 tangent theta. And notice how you started with 8 secant theta, you plugged it into the root, and it gave you 8 tangent theta. So that's just to remember. Okay, so our substitution is, I guess, 8 secant. Dx would be, okay, so derivative of secant is secant tangent, but 8 we keep. So this is going to be secant theta tangent theta, right? And we just figured out from the square root that that's 8 tangent theta. Okay, so now we have to take this integral and translate it to theta language. So think of it as like this. You started with English, so started with x integral. You translated it into Spanish, okay? And then you're going to do something with it. So let's translate it from x to theta. Okay, so we've got x squared. We got that square root. We just figured out what that is. And we also have dx. Remember, for trigonometric substitution, don't just take dx and drop it or something, think it's 1. It's not. We found it. That's derivative. Okay, so we got 1 over. So what is x squared? Well, your x is 8 secant. So square 8, that will be 64. And then square secant. Okay, so I got that. Then it's the square root. We just said that that's 8 tangent theta. And then our dx, we got that. That's 8 secant theta, tangent theta. And then d theta. Okay, so what do we see now? Well, we're going to start canceling things. Okay, so we can cancel. First of all, we see tangent here. That cancels with that tangent. 8 here cancels with that 8. And also one of the secants will cancel, and you're only going to have one left. So supposed to be black. Okay, so we wind up with 1 over 64 secant theta, right? However, you're almost done. Yes, but how are you going to integrate that? Well, if the secant is on the bottom, that's really not good because it's not ready for integration. So first of all, I'm going to pull out 1 over 64. And you need to use the reciprocal identity because secant theta equals 1 over cosine. So always remember that the letter flips. So if you start with an S, over here you're going to have a C, right? And so 1 over secant is going to be cosine, right? So it works both ways. Okay, so if secant is on the bottom, you can pull it to the top and it just becomes cosine. And there it is. Okay, so that's your what we call step 1 of the trigonometric substitution. We just converted stuff from x to theta. So like from English to Spanish. Okay, now what's going to happen? Well, now it's going to be the Spanish part. Okay, somebody translated it. They asked you a question. ¿Cómo estás? Now you have to reply. Muy bien. Okay, so this muy bien thing, well, that's integration. Okay, so we're going to take 1 over 64 cosine theta and integrate that. And luckily, it's a very simple integral. That's just going to be sine theta. So you translated it. They said to you, muy bien. Now you have to translate it back to English because the English-speaking person does not know what that means, okay? So how do you go back from theta to x now that you integrated it? Well, you use what we call reference triangle, okay? So for the reference triangle, how do you know how to label the sides? You have to go back to whatever your substitution was. So my substitution was x equals 8 secant. Okay, now divide this both sides by 8. Okay, so then you're going to get x divided by 8 equals secant theta. By the way, sometimes there is no number in the front. If this was no number, then it would just be secant theta equals x, but then you can write x as x divided by 1. Okay, so that to know what's what. Now, we know the rule, right? SOHCAHTOA. We know that rule. And that tells us how to, like, sine is opposite over hypotenuse. So what's what? This is your angle theta. What is opposite to it? Well, this side is opposite to it, right? This side is adjacent to it. And this is a hypotenuse. Okay? So we know that cosine is adjacent side divided by hypotenuse. But what about secant? Well, we just said the secant is 1 over that. So instead of adjacent over hypotenuse, you're going to have it hypotenuse over adjacent. So this is going to be hypotenuse divided by adjacent. So what that means is that x is the hypotenuse. And that also means that 8 is the adjacent side. Okay? So now we can label it. So our hypotenuse is x, and our adjacent side is 8. So let's put that here. So x goes here, 8 goes here. Now, here is a very important point. The other side, like the other unknown side, must match the root in the question, the square root in the question. So we had that square root of x squared minus 64. And that has to be this other side. Now, how do I know that this is correct? So I will put that square root x squared minus 64. Well, you can verify this by using trigonometric Pythagorean identity, basically, right? So we know that the square of one short side, so that would be 8 squared, plus square of the other short side. But when you square root, that will go away. should be equal to hypotenuse squared, but the hypotenuse is x, so you've got x squared, and notice how this and this will cancel, and you got x squared over x squared equals x squared, which means that you got it right. See? Okay, so now we have to translate the muy bien back in English. Very well, right? Okay, so I've got 1 over 64 sine theta. How do I translate that? Well, all I have to do is look at my triangle. What is sine? Well, that's opposite side divided by hypotenuse. So it's going to have opposite side, which is that square root, divided by the hypotenuse, which is x. Okay, so now we got it. Now we got it. Let's go ahead and put it together, except I think they like to put that 64x on the bottom. So when we multiply fractions, we just multiply straight across. And that's going to be our answer.